Hi students, welcome again to Lectures Club, and today we are going to talk about how to use BJT as a switch. In the previous lecture, we talked about BJT modes of operation like cutoff mode, active mode and saturation mode. If you want to use BJT as a switch, then you have to use BJT in cutoff mode and the saturation mode. Before directly going to today's topic, I would like to remind you how BJT goes from saturation mode to cutoff mode. If you understand this point, I mean how BJT goes from active mode to saturation mode, then definitely the game behind how to use BJT as a switch will be just a moment away to understand. Let's start our today's lecture. Let's start to understand this point with the help of a very famous example of water tap. You will find this example everywhere on the internet. Here you can see that a meter is the water is coming from the emitter, base is controlling the flow of water, and water is coming out of the collector. So when you will open this handle, handle of the tap, water will come into the emitter and will come out from the collector. Similarly, if you open the handle, water will come from the emitter towards the base, and then it will enter towards the collector, and more water is coming. You keep on increasing, you keep on opening the tap, more and more water will come from the emitter and will come out from the collector. A point will reach when you will maximum open this point. This handle has been reached at its maximum point. So at this point, maximum amount of water will come from the emitter into the base and then will go into the collector. Even if you dismantle this handle from the tap, this will not make any difference, because maximum amount of water have already been entered into the base as well as into the collector, because this diameter is the same. So even if you dismantle this handle, this will not increase the water. Now keep in mind this example, and we try to understand the same concept here in case of BJT. We take the example of NPN transistor. This transistor is in active mode. We take the example of the active mode. Let's say we have applied 1 volt at the emitter, 2 volt at the base and 3 volt at the collector. In this case, this junction is forward bias and this junction is reverse bias. So BJT is in active mode. So when you will forward bias base emitter junction, definitely electrons will enter into the base. Red circles representing the electrons. Electrons will enter into the base, and electrons will also go towards the base, towards the collector. Electrons will enter from the emitter into the base, and electrons will also move towards the collector. Why? Because base is at positive potential, so electrons will be attracted towards the positive potential, but base is lightly doped, very lightly doped as compared to emitter and collector. Emitter is very highly doped because current is coming from the emitter, or electrons are coming from the emitter, and collector is lightly doped as compared to emitter but very highly doped as compared to base. But the size of collector is also huge because there are already free electrons. Collector have already its own free electrons, and free electrons are also coming from the emitter. So size of the collector is huge as compared to emitter, and base is very thin and very small as compared to emitter and collector. So when electron will come into the base, very small amount of electrons will be able to manage or to remain into the base, or they will make the combination with the holes, and huge number of electrons will be attracted towards the collector, because collector is also at higher potential or positive potential. And 3 volt, 3 volt, collector is at 3 volt and base is 2 volt. 3 volt is more positive as compared to 2 volt. So more electrons will enter into the collector. When you keep on increasing the voltage, let's say base has this, at this point base has 100 holes and 10 holes have already been filled. Let's say base has 100 holes. So when you will increase more base voltage, let's say base voltage is now 2.1, potential difference has been increased between the emitter and the base. So now more electrons has been entered. Let's say 1000 electrons entered into the base, and only 10 electrons manage to make combination into the holes. So 10 electrons will be in the base, and remaining 990 electrons will enter into the collector. Okay, because base is very thin and there is a huge pressure of electrons from the emitter, so more electrons will be pushed towards the collector, and also because of this positive. You further keep on increasing the voltage. Now the base voltage is 2.2. So let's say more 1000 electrons have been entered and only 10 electrons able to manage or able to make holes, able to make a combination with the base, or are coming out of the base. So remaining 990 electrons will enter into the collector. So now the base has 20 electrons and collector has 990 plus 990, 1980 electrons. Here this part is very crucial. You can see that very small change in base current producing a very huge change in collector current. You can see that in active mode, with a very small change in base current, a very huge amount of collector current is also changing place. So with a very small input, you can produce a very high output. This is a very famous example, or you can see very famous application of BJT. BJT is in BJT working as an amplifier. So you keep on increasing the voltage, so potential difference is increasing, so more and more electrons are coming and they are capturing the holes. A point will reach, let's say for every 0.6 second 10 electrons capture the holes. Now when you reach at 3.0, when you will reach at 3.0, now the all completely 100 holes of base are filled. Base is completely filled now, and more electrons have been already entered into the collector. For every 10 electrons, I say 990 electrons have been entered into the collector. Now when you further increase the voltage, you will increase to 3.1 or 3.2, base is now completely filled. Base is not going to accept any electrons more. Base is not accepting any electrons. Before that, previously electrons were coming out into the base, but base was very thin. Electrons didn't find any holes for them, or didn't find any space to keep or move into the base. So there was also a very huge push of from the electrons coming from the emitter, and the electron will be pushed. Electron in the base will be pushed towards the collector. A collector is also attracting the electrons. So electrons were not able to manage or stay into the base because base was already very thin. So when you will increase 3.1, now base is not accepting any electrons. Okay. Now the base has gone into saturation. So keep in mind the number of electrons coming into the base, they are going towards the collector. So if base is not accepting any more electrons, how collector can accept? Because collector is dependent upon the base. The number of electrons entered into the base, out of which number of electrons coming towards the collector. So base is no more accepting the electrons. So the current at the base and the collector has gone at the maximum point or at constant level. So further increase in the base voltage will not make any difference, and the electron will throughout the NPN transistor will be at constant level. Now we say that base and collector has gone into saturation mode. Here you can see that now the base voltage is 3.2 volt. Base is positive at 3.2 volt and collector is at 3 volt. So N-type region is at lower potential and P-type region is at high potential, and we can say that this junction has been also gone into forward bias condition. This is very this point is very important. If you want to use a BJT as a switch, definitely you need the flow of current, or you don't need the flow of current. You want zero current, or you want some constant value of current through the BJT. So you can achieve these these two modes, cutoff mode and saturation mode, at the same time, and BJT can work as a switch too. You can see that 2 volt is the amount of base voltage. We increase the base voltage to 3.2, increase which is greater than 3 volt. So when you want to switch off this BJT, simply cut off, switch off the base. Definitely what will happen, no electron will enter the base and no electron will go towards the collector. And if you want to make this BJT to work, or you want a constant current flow of through the BJT, definitely the base voltage should be greater than the collector voltage, and you give more voltage as compared to collector. So when base will be on, these two junctions will be forward biased and a constant flow of current through the BJT will take place.
Now for more precise understanding, consider this common emitter
circuit, which is this transistor is NPN transistor and the circuit is common emitter. If we cut off this transistor, definitely what we need to do, this VBB must be equal to or lesser than the emitter voltage. If VBB is equal to or lesser than the emitter voltage, definitely the base emitter junction will be reversed biased and no current will flow from emitter towards the collector. And if we want to turn on transistor and we want to turn on in saturation mode, definitely what we need to do, I briefly explained you, this base voltage must be greater than the collector voltage. If base voltage is greater than the collector voltage, then base collector junction will be forward biased, and base voltage is greater than emitter voltage, then this emitter base junction will be forward biased. If both junctions, base emitter junction as well as the base collector junctions, are forward biased, then definitely what will happen, this transistor will go into saturation mode and constant current will flow through the transistor. I hope you liked the video. If this is true and you have understood all the concept, don't forget to like the video, share the video to spread knowledge, and don't forget to subscribe my channel. See you in the next tutorial. Bye bye, stay blessed.